Where's it going? It's just in the
Alright, guys, start by the warm up.
No, it's in there.
Sorry, we will
It'll come out.
hopefully finish the practice.
I just wrote, I know this goes to E to 5, but I don't know how. I got 3 out of 4 points.
I like everything that goes into your heart, so I'll get it has it.
No,
Some people.
I got 30.
Alright, guys, this, please.
Oh, it's actually me.
So since it's on, you start with
6x minus 2x.
no, but then you have to do, it's not minus 12, you have to do the equals. So you do 6x plus c equals 5. So it's 18. Like it,
That makes sense.
like, say, 6x plus c equals minus 12.
Okay. So, guys, to review quickly yesterday, and to show you some notation. If they want the 4th degree polynomial that approximates this, which is not the question they asked for just a single term, that 4th degree polynomial, they would write it like this. The function and the polynomial need to match at that coordinate. Then it's first derivative, x minus the center to the first power over 1 factorial. Do you need to write to the first? No. Do you need to write to 1 factorial? No. Plus second derivative, x minus the center to the second power over 2 factorial, which is also known as just 2, so you didn't need to remember the exclamation point. Plus third derivative, x minus the center to the third over 3 factorial. Now the exclamation point matters. And then the fourth one, fourth derivative, x minus the center to the fourth over 4 factorial. So to answer the question that was actually up here, what is the x to the third term? This is often a multiple choice question. So negative 12 divided by 3 factorial is 6. So they will either ask what is the term or what is the coefficient of the x to the third term. Yes, no? How do you do it? Huh? Okay. Very similar question, but different. They will also get you in your little log too with this kind of question. Like what? How do we find out if functions have a max or a min? Do the first derivative and, okay, if the first derivative is 0, what do we know? What is going on at x equals 3 for this function f? Okay, by definition of critical point, if the first derivative is 0 or undefined, it's a critical point. Does it have to be a max or min? No. Could it be? Yes. If it's any number other than 0, can it be a max or min? No. It's got to be a critical point. And it is. All right, how do I know if it's a maximum, a minimum, or something else?
You gotta like keep the number line thing.
I don't have a number line. I don't have anything. I don't know anything except these derivatives at x equals 3. I don't know anything. Can't do a number line. So there is another thing we could have done. Okay, which other, which we look at?
The double is that's concavity.
The double derivative, concavity, all right. So Kai, the double derivative is 11. Concave up or down, which one? Up. So Preston, that critical point, is it a maximum or minimum? Minimum. So they can force you to use that, it's called the second derivative test. Because a lot of you are like, I'm not gonna even bother, I'm just forever gonna do the number line. Well, all right, wait. Didn't give you the function to test the number line right away. So, just showing you, there's this. Okay, back to the regularly scheduled program. We did not get nearly as far as I expected yesterday, and I forgot that we needed to jump this high to do the homework. Sorry about that. Center of convergence is where we start to anchor things down. When we find a tangent line, I have to tell you where I want it tangent, and when you put down a Taylor series or a Maclaurin series, you need to give the coordinate where you're going to anchor it down. Wherever it's anchored down, that's the center of convergence. It's like where everything is exactly accurate. The polynomial and the function are exactly accurate at that center. And then things degrade a little as you go out. The warm-up yesterday, we did all of these guys. And if I was to create the polynomial, Grady, what's the first thing that needs to match up? Like, what's the constant of the function? It's the value of the function at the center 0. Zero. So the polynomial needs to be 0 at the center as well. The next term, I need to make the first derivatives match. So using the pattern rather than integrating up, can anyone tell me what the next term should be? To create each term, it's the nth derivative at the center, x minus the center to the n over n factorial. My center is 0. So to get the first term, x minus 0, to the first 1 factorial, what is the first derivative evaluated at my center? 1. Okay. Plus second degree, 2 factorial, second derivative. Okay, a times, looking at the chart, is 0. Plus third degree, 3 factorial, third derivative, -1. Okay, now we're catching on. Ooh, that's a 4. If you look, every other derivative evaluating at the center became 0. So all those even terms go away. So shrunk up, polynomial that approximates sine has this pattern. Is this pattern geometric? Up top, I'm multiplying by -x squared. On the bottom, I'm not. The factorials are not they're not geometric pattern. Well, let's look, what does the question ask us to do? Construct the 8th order. Order and degree are usually the same. Order is do this many derivatives. I did 8 derivatives. That is my 8th order, though, because x to the 8th had a 0 coefficient. So x to the 7th order and the 8th order for sine are the same. They're not going to make a big deal about it. Just order is usually equal to degree, not always. Let's see. Ooh. We want to use this estimate to approximate sine of 0.2. Okay. So take out your calculator and then the pain type in.
Are you kidding?
It's not in
Yeah. PRD, probability. Factorial on your calculator. So under the math key, arrow over to PRB for probability. For whatever reason, I always read it as peanut butter jelly.
That's crazy. That sounds
What? So I had to go out 12 decimals till they finally got different. That's a lot. I think we went a little overkill on our accuracy. Still makes me nervous that I have family and friends that use this and they're like, oh yeah, no, we're just one. Like, okay. All right. So my polynomial approximates sine really closely. Yeah,
So how many decimal points do you need if you're like leaving it as an answer?
okay, we're gonna do error next. So we'll get to the error later. Right now, I just wanna see if we got the pattern. So this is one of the patterns we ask you to memorize. But I wanna find an nth term first. These guys already did it. How can I find an equation for that nth term? Any ideas? Is it x to the n? I'm gonna need x to the something, and -1 to the something, and whatever the exponent was, I want that factorial in the bottom. Nick?
X to the 2n minus 1. So that you're like getting odd and then you put that in the denominator as well.
Okay, so pick any number, any whole number, double it and you get an even number. Add one or subtract one, right next door is an odd, so how do you force any whole number to become odd? Make it even and add or subtract one. All right, so Nick, if we do this, it looks like your n value would start at 1. So you would say, for the sigma notation, all of the terms that make this work. Oh, and you said x to the n. Let's see. And I want the first term to be negative or positive, so I need to shift that. To work? And you don't necessarily need to memorize the sigma thing. You need to know this expansion, be able to create it. And it shouldn't be that hard. Sine is even or odd. Does it fold over the y-axis or does it spin around the origin? It's even or odd. Which spins around the origin, so it's odd. Oh, well, that's convenient because all the exponents are odd. The signs turn on and off. First odd number is 1, so it goes 1, 3, 5, 7, 9. And we're dividing by that factorial. Yeah.
What changes when you do 2n plus 1?
What changes when you do 2n plus 1? Now we start at 0,
It's just
and okay. Okay, so yeah,
Wait, how do you start the process of figuring out how to create that?
okay. We did this. How did we create it? We did all the derivatives, and then we forced every curve of my curve to match. So yesterday, the way we did it was we integrated up each time and forced the plus c to match what we got each time.
Sorry, I meant the, with the equation that we just got.
This guy?
Yeah.
Well, seems we have x's, and Nick noticed the exponents were all odd numbers. So to force an odd number, create an even, and plus 1 or minus 1, your choice. Right next door to every even is an odd, so which one do you want? Plus 1, okay. So whatever the exponent up there was, matched the factorial below. And then the sign turns on and off. Okay, I wanted the first exponent to be a 1, and you don't need, if they don't ask for sigma notation, you don't need to tell them. You'd be like, I don't know, maybe it's this, but you need to make sure you get their negatives correct. When n is 0, I get x to the first over 0 factorial, which we gotta remember is 1, and -1 to the 0 is positive. I wanted the first term positive, I got it. So when n is 0, I get an x. Now let's go to n is 1. That's x to the third. -1 to the third, or sorry, -1 to the 1 is negative. over 3 factorial, I got the next term. Maybe check one more to make sure that your expansion works. And if you're off by something, maybe you need to adjust +1 or -1, fix it.
Right, thank you.
This is written on the back of your packet, and I'm not feeling the time to generate it, but we could do all the derivatives. Cosine's even, so it has all the even powers. The signs still fluctuate. So Sydney, take a stab at it. How am I gonna create
So, numerator is gonna be x to the power of 2n. And the bottom is gonna be 2n factorial. And then the power of -1 is going to be n. And maybe.
Okay, so let's check. When n is 0, 2 times, okay, so that's to the 0, that's a 1, over 0 factorial, which is 1, -1 to 0, okay, we got the first term. Now, when n is 1, I get x squared times -1 over 2 factorial. Yeah. Voila. Okay. Be careful in the questions. Are they asking for 3 terms? Are they asking for the 4th order? Are they asking for the 4th degree? Order and degree, usually exactly the same thing. So 4th order and 4th degree means the highest exponent is that number. Do not break the rules on that. If they say, give me x to the 4th, only give them x to the 4th. Don't be like, oh, I'll add a couple extra for fun. No, don't do that. They get mad. Okay. Here's the really nice thing that I didn't get to tell you guys yesterday. We just said cosine is approximately, okay, it's all evens. First even power was 0, so 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. Kai, this is asking for 4th order. Do I need to stop here or do I need another term? Stop there. 4th order is usually the same as 4th degree. So that's cosine x. I wanted cosine 2x. Camden, I think you're gonna like this. You ready? Cosine of 2x. What do you think I'm gonna put in the parentheses that I created?
There's 2x.
Does that work for anything?
Okay. Works for any polynomial. So if you wanted to do sine of natural log of x, which I don't know what that looks like at all, can't do it. Natural log is in a polynomial. Sine of e to the x, no flip included. Sine of 2x squared plus 3, never tried it, but that would work. Ready?
Go back to the order and the, what was the step, where was the difference between those?
Okay. Generally, there is no difference between order and degree. Order is, you had to do 5 derivatives to get this answer. For cosine, every other one, just like sine, every other derivative evaluated to 0. So for sine and cosine, 4th order and 5th order are gonna have the same polynomial. Like, and they, AP does not pick on that. They should be the same. Okay, so this one, all you gotta do is like take the polynomial and stuff it in there. please be careful to use the parentheses because this is negative 4x squared over 2 factorial. Because the exponent goes to the coefficient as well. Okay. And they make the point that they can move the center. Big deal. All right, there are these 3 problems on that page of the packet. Any suggestion on how to start it? Do sin x, then do cosine x and add them. Yes, do that. Do you go forever? Just stop when you get to a degree that's 4. So try it.
Yeah.
Yeah.
Just stop at 3 or 5.
Because the next one is too big.
It's too much. Okay. Yeah, okay.
Yeah.
Oh, wait, I have something to say about that. I actually read the answer. Let's see what's wrong. This is first floor charts. Actually, gives
And you don't need to evaluate the factorials. You can just leave them as 4 factorial or whatever. You guys okay with the first one?
How much do you say the last?
Just like.
So, guys, yeah, how do you do the sine and cosine expansions quickly? We ask that you memorize them. And hopefully, I mean, the little thing of sine's odd, so it's all the odd powers and the power fluctuates and it's the factorial. And cosine, it's even, so starting with first even power, which is x to the 0, blah, blah. But what's your question?
So if it wasn't, like if you were given different functions that weren't sine and cosine, you would have to go through the name.
Yeah.
Fun pattern.
The only ones I have memorized, sine and cosine. E to the x is easy enough to generate. Like, if you look at the back page of your packet, they're the popular ones. And again, I don't memorize them. But Sydney, I can quickly create the sequence that is this one, because this looks like that geometric. First term times R times R times R. And then if I integrated this, I have natural log of, well, and then I could integrate each thing and get the answers. Nick, what were you saying about number 2?
Well, I was thinking about how, like you just said, about how we can swap out the 2x, but, and then, it would be possible to divide by 2 for the whole thing, but the addition, like, messes it up, and how maybe it's a double angle formula, I think it's or if you just, like, if you add one just at the beginning to the first term in the series, or if you add one continuously for every single piece.
Okay, so let's see. Cosine 2x will be the cosine formula expanded. And when it says give the first 4 terms, I'm gonna keep an extra 1 or 2 because sometimes they combine. Sometimes like multiply by 0 and something disappears. So I'm gonna keep an extra 1. And Fiona, how did I manage when it wasn't cosine of x but cosine of 2x? What did I do? Put the 2x into the parentheses for all of these guys. All right. So I have 1/2 plus 1/2. Oh, right there, a term combined. So, they will write things like this on a multiple choice. Let's see. These combine to become a 1. So that's 1 term, 2 terms, 3 terms. I needed that last one. They do not expect you to do the math out. 2 times 6 factorial, leave it. Oh, crap, I need a general term. How do I get a general term? That's that. Alex, any ideas? Is there something that's on every single term? Is it like, okay. It looks like we have even powers. And that denominator is gonna have whatever that power is, 2 times that thing factorial. And this looks like a 2x. And I need a -1 to turn on and off. And that front 1 always bothers me. How are we gonna manage that? Maybe we can do that. How do I, what does n have to be to make my first term work? 0? If this is 0, I get to the first and a -1 and a half. So I think I need to have the 1 plus, and I want n to start at 1. I have 1 plus, and then the rest of that, I have a general term.
When you're like saying like the first 4 terms, like those are the first 4 terms in like the cosine of 2x like, series. So then could you just start that way instead of like thinking, you know,
Well,
what extra term were you moving to? As the first
because 1/2 counts as a term, but that 1/2 combined with another number from my series. Sometimes it, like if it was sine, it would have been 1/2 and then an x, and then, so I would have had an extra term that I didn't need.
You can always just like add like a lot and then cross out what you don't need later, right?
Yeah, you don't want, okay, in the effort put into it, you don't want to spend a lot of time creating stuff you don't need. So get an extra 1. And then, you know, maybe you'll need another. How do you think we have to deal with number 3?
You could just do the, like sine series and then just multiply by x each time, so it's just like, instead of x as the first term, it's x squared, and then minus x to the 4th over 3 factorial, plus x to the 6th over 5 factorial.
Yes. So then it turns your sine series into a bunch of even powers, which is awkward. But yes, exactly what he said.
It just asks you to expand that. Could you leave it as x times all of that, or would you still have to like, how much do you have to simplify it?
This,
That would be needed, but like if you didn't have to for a general term.
they're gonna make you do something.
Okay.
Now my power and my factorial thing in the bottom don't match.
The x is 6 over 5 factorial.
Thank you. Massimo, how do I get a thing to give me the x, the a sub n term?
I would do x to the 2n, and then in the denominator do 2n minus 1.
And then I need a -1 to turn on and off. Okay, so if n is, what does my n start with to give me the right beginning? 1? Okay, so that gives me x squared. I need to turn the negative off. Down here, that gives me to the first factorial. Okay. When n is 2, I get x to the 4th, and that's a negative, and I get 3 factorial down there. Seems to work. Okay, so guys, try that one more